Hey guys, we're going to look at some of the homework problems from last night. So this one, the first one here, two tugboats are towing a loaded barge and the magnitude of the resultant is 2,400 pounds directed along the x-axis of the barge. So here's my x-axis right here. It's the direction it's going in. So find the tension in pounds in the tow lines that they each make an 18-degree angle with the axis of the barge. So you can see they've got 18 degrees in each direction, which if I'm considering this like my unit circle here, then this one down here, this 18 degrees down here, I can consider it 360 minus 18. So we're at 342 degrees. All right, for the unit circle. So for the A vector, it looks like it's got this magnitude, I don't know what the magnitude of that is, times, and then I do know the direction, isn't that positive 18 degrees? So I'm gonna go cosine of 18 degrees plus sine of 18 degrees. All right, so this other guy down here, vector B, they've got their magnitude, it's the same magnitude, which I'm trying to solve for that magnitude, but the direction looks like 342 degrees. Okay, now these two added together is going to go to where the boat is going, down the middle here. That's like between your positive 18 and negative 18 is 0. So going down the x-axis at 0 degrees. So what I want to do is the A plus B. So oh, I didn't put the I and the J in here. Let me put the I and the J. Like horizontal and vertical. There we go. There's my I and J. Forgot those. Okay, so I've got, there's my A plus B. So let's see here. The thing I can notice that might make things a little quicker and easier is that on my unit circle, sine has to do with all the y values. And these angles that we're going at, it's a positive and a negative of the same y value. So this like sine of 18 degrees and sine of 342 degrees are going to be a positive and negative of the same thing. You're welcome to put it in your calculator, but they add up to 0. I'm kind of done with those. And then that leaves me down to just the cosines. All right, which if I factor out the magnitude here, which is what I'm trying to find. So yeah, find the tension in pounds. I'm finding the magnitude essentially. Let's figure out what this is. In fact, the fact that it's I just means I'm going horizontally. So I'm not too worried about that. I'm going to figure out what this cosine stuff all adds up to. And I do know that they said here, let's highlight this, the resultant is 2,400 pounds directed along the axis. So this magnitude here, this guy right here should be 2,400. So I'm gonna make my A plus B into a 2,400. All right, so then let's see, I'm gonna bust out my calculator and my mode here in degrees. Okay, so it looks like I'm gonna do the cosine of 18 degrees plus the cosine of 342 degrees. All right, there's my messy decimal, but that is really, all this is multiplied by my magnitude, which is what I'm trying to solve for. So I'm going to divide that incredibly messy number, which looks like, yeah, 1.90, but I'm going to keep that whole thing in my calculator. I'm going to divide that over and get my magnitude. The direction is taken care of with the I. I'm not really worried about the direction though. I know this is going horizontally. I'm just looking for the magnitude. So I'm going to do my 2400 divided by this whole entire messy decimal. Okay. So this is 1,261.8 if I go to the one decimal. So that's kind of what they have right here. And like I said, for vector A and vector B, they're both pulling the same amount, just in different directions. So they both have the same number of pounds. All right, so I hope that helps on this guy. Let's look at next one. All right, so a force of F pounds is required to pull an object weighing W pounds up a ramp inclined at theta degrees. Okay, I'm gonna try to draw something here for that. You got a ramp. I'm gonna make this into a right triangle. Here's my W on my ramp. Here's my theta in degrees. Find F if W is 110 pounds and theta is 16 degrees. Let's see, where's the F? A force of F pounds is required to pull an object weighing W pounds up a ramp. I think that kind of tiny little word, it's, not telling me that I'm going to the side, I'm going up. So I'm going to put my F right here. All right, so the information they gave me was the 16 degrees for theta and the 110 pounds for W, which it looks like I've got, according to theta, I've got the opposite in hypotenuse. So I'm probably going to go with sine of this 16 degrees is the opposite over the hypotenuse. All right, so I'm going to multiply that 110 over to the other side and solve for F. So let's see here, my, oops, 110 times sine of 16 degrees. All right, 30.32, I guess 30.3 if they want me to round to one decimal place. So 30.3 pounds, that's where this came from. All right, I hope this helps you guys. See you later.